Okay, good morning, everybody. So I am Giuseppe Amatulli from Spatial Ecology and also work at Yale University as a for geocomputation application and machine learning in general for environmental application. We set up this course from many years with different variation in according to the skills of the students, also to the different speaker that we invite. Spatial ecology has his main courses in the south of Italy that was carried over for several years. Probably some of you heard about because some of the colleagues of your colleagues, previous colleagues, they were in our summer school. We set up this course last year during the summer, but then during the pandemic for the Swedish people was cancelled. So we, thanks to Otto and to Carmen, we were able to enroll once again for the full semester for 2 months. The full semester course or the half semester course, let's say 2 months, is I would consider it is a bit better than an intense week of training, or 1 week training, because give you the time to digest it, to self-working by yourself during the days we don't have lectures. So I strongly encourage you to keep going with exercise and reading and testing code and so on during the afternoon and the day after in order to achieve better statement the day after that we are coming. I ran this course together with Lonzu. Lonzu, you can say hi to everybody.
Hi.
Yeah, and so I just mailing all of you the presentation. We are going to use it maybe just this time or maybe even next time, this sending presentation rather than not GitHub. And as soon we will have in GitHub, or at least you guys who have set up all the GitHub, we will use mainly GitHub as a main source. So I'm going to share my screen for the presentation. Okay. Perfect. I think you can see now. So we are going to meet every Tuesday and Thursday, as I mentioned in my email, from 2 p.m. to 4:30 p.m. The video record is starting half an hour early and ending half an hour later, in order to avoid some troubleshooting, especially after to allow the people stay longer for some troubleshoot or for additional explanation and so on. Learning objective of the course. We are going to do GIS and remote sensing application. You guys have a quite good level, or at least most of you level of GIS and remote sensing. So we will not see, let's say, the basic, but we will go directly with application in geographical data. We will cover spatio-temporal analysis, and we will have everything under the Linux operating system. Some of you, again, have already implemented or using daily Linux. So we will try to merge the expectation from advanced people, even with also all the people that are a bit more beginners or intermediate level. And we will try to push you forward, not only from the technical aspect, but also for the critical thinking, independent learning. This is something that is really important, the independent learning, because we never finish to learn and looking for solution in internet or in mailing list and so on. We will see machine learning application, and Lunzu will give you also a strong background in the machine learning statistical and mathematical framework that is behind. So we will see not only the application as it is, but try to understanding why we need to use it, machine learning, how machine learning can help in discover new pattern and discover new relationship inside to a big amount of data. So this is the typical situation of some of you, let's say, or you have been already in this kind of situation in according to the to the starting of using open source, especially in the beginning, and maybe people that are a bit advanced can already say that several times they've been tried, but then there are several failing action. So during the course, for the people that are in beginning, we will try to push forward this point of failing in order to keep and giving the tools to keep climbing by themselves. Rather than for the people that they are already advanced, we will try to push forward to this line and give you tools and statistical background to push forward your analysis. So we will try to reach for all of you a good wide understanding and skills in processing data. We will do it spatial temporal analysis, spatial temporal data integration in different kind of source and application. And of course, we will cover geostatistics and machine learning, like I mentioned before. So the tools that we are going to use it, they are going to be GIS remote sensing tools. We will see GRASS and QGIS. QGIS we will only see for, let's say, graphical user interface and just to look at the data. So it is going to be a really minor situation. So we will focus mainly in the command line. So we will see GRASS from an initial point, but also more advanced analysis in GRASS, like hydrological modeling. We will cover several applications in Python for machine learning. We will have invited speaker to cover also machine learning in different domains. Of course, we will work a lot in the Linux Bash terminal. We are people, Lonzu and I, we are people that we try to combine. We don't focus only in Python, only in R, and so on. So we try to combine as much as possible different language. So we'll learn also language integration, how to communicate between Python and Bash, between Bash and GDAL, MPK tools, and so on. We will see also a bit old-fashioned, let's say, old-fashioned scripting language like Oak for massive data process text file, because it's still one of the most fastest one. And we really like to teach, maybe not really deep, just a few tips. When I started years ago, I wrote really big code, like 20-line Oak, but now with 1 or 2 lines is more than enough of squeezing the data and take what you want, and then bring inside Python or inside R for additional analysis, maybe with more statistical analysis. Rather, for the simple column and row selection will be easy to do, is easy and more efficient to do under Oak. Then we will see also the super command line and geographical data, so GDAL, OGR, and also PK tools. Some application with the CDO. CDO is for climate data operator. You guys coming from the climate science, I think, heard about this. And the use of CDO, climate data operator, together with Bash, really give you a big strength for processing net CDF data. So this is very appealing. All our material will be in the spatialecology.net, docs, build, HTML index. This is the new format that we are still updating during the lecture and so on. So it was born during the pandemic. Before this one is the old one. That is a bit static, let's say, is not developing anymore, but there is a lot of material over there that is coming into the new one with some refreshment and of course improvement and so on. But feel free also to navigate inside to the old one, where you can find a lot of application in GIS for language integration and so on. Now we will have a little round table among us where you were talking about your skills. So I will start from myself, let's say, in order to understand more or less follow the same structure. You know, I mentioned that I'm working over here at Yale University, and I'm really the guy that should bring the bridge between environmental science and computation. So I study forestry, so I learning computing and statistical application and later on machine learning by myself. So I always say I'm not a computer scientist, so but I try to transfer this kind of application and the environment application inside to the computer. So this is quite appealing because give you the tools to achieve something that, let's say, your colleagues are not able to achieve it because they will not able to use the command line. So for people in the beginning, a bit scaring in the beginning, but then we will go through this journey quite all together. So as I mentioned to you, I started 20 years ago inside to the Bash command line. And then later on, I learned R and Python and so on, and all the geographical software application. And now I combine all of them. My strength is more Bash related and R, and using Python from time to time when I don't find tools that are able to achieve my goals. So I use programming language every day, mainly in the supercomputer over here at Yale University, where I combine all the language all together. So maybe Lonzu, you can say something about you, and then we start with the students.
Yeah, sure. So I'm like Giuseppe mentioned, I'm a colleague with Giuseppe. We've been working together several years. I met Giuseppe when I was at Yale University, when I was working there. And later on, I transited to University of Cambridge, which I still located right now in UK. My technical background was quantum chemistry, basically application for quantum mechanics principles into the chemistry domain. So I would describe myself as a mathematical modeler. I like to view the problems from the lens of mathematics, and I code and program. I'm also claim myself as a scientific programmer, but I code and program for the purpose of modeling, basically serving the need of a mathematical model. I started coding quite early, even begin with C, C++, and even a bit of Fortran. Of course, later on with the rise of script languages, the R, Python, and others, Wolfram languages. So I code all of them. But like once again, I normally code not for the coding purpose, but for the scientific modeling purpose. I'm also a Linux enthusiast. I had experience working with all kind of Linux distributions, the mainstream distributions. I also work with the BSD system. My daily work base is a Linux machine. So I'm quite happy to work under the system. It empowers me to do a lot of things much more efficiently and in a much more professional way. I think that's more or less about me. We can translate to other people.
Yes, thank you, Lonzu. I was not fine, my microphone. Okay, go ahead. Next one. Alicia, maybe. I'm starting from my first one. Yeah.
Yeah. Hello. Can you hear me? Yes. So my name is Alicia Valdez. I come originally from Spain, and I'm now working as a researcher at Stockholm University at the Department of Ecology, Environment, and Plant Science. And so I'm currently working more on things related to evolutionary ecology, especially the relationships between climatic variation and variations in flowering times and things like that. But I have previously worked more in landscape ecology, issues related to forest fragmentation. So in those years, I used, I was working with GIS, but mainly using ArcGIS and also a bit of QGIS. So I thought it would be nice to sign up for the course in order to get like a more broad knowledge of what is possible with open source tools. So basically, I don't think I'm going to use what I learned in the course at the moment, but I thought it will be really nice for future applications. And what else? So I don't have any experience with Linux or Grass or things like that. And for programming languages, I mostly know about R. But nothing else, nothing about Python or so. So what I mostly expect is to get like a general view of which tools are available and what can I use for geocomputation in an open source framework. Yeah, so that's it mainly.
Thanks, Alicia. Alexandra, you are next on the.
Hi, can you hear me?
Yeah.
Hi, everyone. My name is Alexandra. I'm a PhD student at the Department of Physical Geography in Lund, Sweden. So originally, I'm from Hungary, but I've been here in Sweden for a while, and I'm stuck. I have a background in physical geography and geomatics, and my PhD project is about modeling the Arctic carbon cycle. For this, I'm using a dynamic ecosystem model. So on a daily basis, I'm using C++ and Python for data analysis. But previously, I used Grass, QGIS, and all other kinds of problems for smaller tasks. And what I would like to get from this course is to be more independent when I'm working on a remote computer, which I do sometimes. And I feel that I have very limited knowledge. I basically get to do what I need to, and that's it. So I think this course would be really nice to feel a bit more empowered in that regard.
Thank you, Alexandra. Yeah. Felicity.
Hi, I'm Felicity. I'm originally from the UK, but I'm currently at Stockholm University in the Department of Physical Geography. And I'm doing my PhD looking at glaciers and ice-ocean interactions, mainly in the Arctic. So I use quite a lot of spatial data for this because I've kind of got half observations and then half modeling as part of my PhD. So I use Linux a bit, especially for like the modeling part. Yeah, in there, and then I have also some R and kind of MATLAB and a little bit of Python, which I use, and then the model I use is in Fortran. And then I kind of use a bit of JS for like looking at stuff, but I feel like I kind of end up just using little bits of everything, and I don't really have like a solid like frame. I haven't really taken a course. I feel like there's a lot more I could get out of it through like taking this course and kind of realizing the full potential of all those different softwares and languages. So that's what I'm hoping to get out of the course. Thank you.
Thank you, Felicity. Yeah. Tanya.
Hi, everyone. So yeah, my name is Tanya. Originally, I'm from Russia, but now I'm Sweden. So I'm doing a PhD in Swedish University of Agriculture Sciences at the forestry department, and I'm working on fire-climate interactions. So yeah, and I'm working with reanalysis data, with observations, and for the data analysis, I'm using normally Python and CDO, and using bash scripting, and yeah, I'm familiar with Linux environment. Yeah, so I signed up for this course just to improve my technical skills, and yeah, thank you.
Thank you, Tanya. Said.
Yes, I'm Said. I'm doing a PhD at the Department of Physical Geography. My background is in geodesy, but here I'm working on hydrology and with geodetic approaches like remote sensing. So I have worked a bit with Linux when I work with remote sensing software. And in terms of the programming languages, I work with MATLAB, a bit of Python, and shell programming, mostly TC shell programming.
Thank you. Salar?
Hi, my name is Salar. I'm from Stockholm originally, but I'm doing my PhD at the University of Gothenburg. I'm a physical oceanographer working with Arctic and Antarctic observations. So it's more observational data sets than modeling and so on. I'm hoping to learn more about machine learning and like feature extraction and stuff like that. Also to familiarize myself with, I guess, Python and how to work in a virtual OS and so on. My current programming language is restricted to MATLAB right now. Thanks.
Thank you, Salar. Carlos?
Hi everyone, my name is Carlos. I'm from Colombia. Well, my background is quite different from everyone because I'm a chemical engineer. But during my master's, I work with well, fossil fuel fluxes. So I started working with ArcGIS. And now in my PhD, well, I'm in the Department of Physical Geography at Lund University. And well, my work is developing a fossil fuel data simulation system to quantify the fossil fuel emissions over Europe. So, well, since my background is not in geography or anything like that, so well, I need to improve my skills in well, the data management, geographic data management. About programming, well, I started working with MATLAB, then I worked with R. Now I'm into Python and Fortran. I'm better in Python than in Fortran. Fortran is, well, I just know the basics because, well, the model that I'm working right now is brought in Python and in Fortran. So well, I know just the basics about Fortran. And Linux, I know how to navigate and do some stuff because, of course, the models are in a Linux machine, but it's not my well, yeah, I'm not that strong. I don't have that strong knowledge. Yeah, that's it. Thank you.
Gracias, Carlos. Rosalia?
Hey, hi, my name is Rosie. I'm originally from Hungary, but I'm doing my PhD here in Sweden, in Stockholm, and my background is in landscape ecology. And I'm working now at the moment with plants and how they are moving in the landscape. So I'm doing mostly like landscape analysis. Yes. And I have experience in R, a little bit of MATLAB experience, but never used Linux before. And I have an overall interest in how to do geocomputation without a pain and how we can proceed very quickly geocomputation. So that's what I'm like expecting to do. And I'm also interested in machine learning, so that's why I'm going to take this course.
Thank you, Rose. Mariana, we know each other already.
Hello, Giuseppe. Yes, so my name is Marianne. I come from France, and I am also at Stockholm University. And well, I'm also a landscape ecologist, like Rosie. I would say that's my main background. And it's true that I already know Giuseppe because I actually took the summer school in southern Italy already some years ago, 2017, I think. And it was really an eye-opener for me. At that point, I was research assistant, and it's really like, it blew my mind because at that point I was just a newbie and I really realized how much you could do and how yeah, how stable it could be to run heavy geocomputation using JDAL and so on. So it was really, really good. And then when I got to start my PhD, I kind of wanted to like go on to completely Linux, but it's true that here at Stockholm University, we still teach GIS on ArcMap or even ArcPro now. So I always had a foot still with this kind of software. Yeah, so now I'm really glad. I mean, I was not planning straight away to take this course, but then I got to see that it would be an important focus on machine learning. And just to let you know more about my project just now, so I'm working with reindeer ecology, and I've put collars on reindeer, also accelerometers, meaning I'm looking into movement in 3D. And so like just now I'm classifying the behavior into different kind of activities and so on. So machine learning would be a very big, like it's definitely a big part of my project just now. So I'm very interested into that. And also something that I would like to know more through this course, hopefully, would be to see how to maybe do multitasking, like parallel processing and things like that, because I'm still feeling like, yeah, I need to learn how this works a bit more. So I think that's my background. And about coding, well, I have a bit of background in Python, but mostly I developed very much in R and JDAL. And yeah, I think that's it. Yeah, that's from me.
Thank you, Marianne. Jacob.
Sorry, I was missing the mute button. So my name is Jacopo. I come from Italy, but I'm also at Stockholm University. My background has been environmental engineering, and now I'm a hydrologist. And in my work, my PhD, I'm working mostly with different water quality data sets. And so I don't have experience with Linux. I've been mostly working with MATLAB and ArcGIS, so proprietary-based programs. But I'm interested in learning Linux because I will expect that at some point I will get necessity to use them. And also I'll start to work with Python. So mostly I work with MATLAB and then Python as a second programming language. And then, yeah, I'm really interested in know better open source programming and other kind of JS program, but also like how to handle more complex data sets that are not just the basis. So once I've got like a time series on a spread out data set, I was like, how I do manage that in Python, in ArcGIS. So that would be good. And also machine learning, as I'm working with large data, I will be interested in learning a bit about how to read data in a different way from a basic linear regression or something like that.
Okay, thank you, Jacob. Alex.
Yeah, hi. My name is Alexandra, or well, since we have another Alexandra here, so I just go by Alex. I'm from Germany, and I'm doing my PhD at Stockholm University right now in the Department of Physical Geography. I have a background in numerical modeling, so during my master's I was doing glacier mass balance modeling. Now I'm doing permafrost modeling in the Arctic. And I've been using mostly R during my master's. Now I switched to Python. I touched MATLAB, but I'm a fan of open source, so I tried to avoid it, which is also why I went from ArcGIS to QGIS in the end, but mostly for descriptive manners, like just plotting maps, visualizing data. And I know it can do much more, so it would be great to see a little bit more of the capabilities. I'm going to use reanalysis data probably, as well as climate projection data, like the RCP scenarios to force my model. So it would be great to get some more maybe tools on how to handle these data. Since I use CDO quite a lot already, but I know that it can also do a lot more. And I'm doing all of this in Linux, and it's almost 5 years now that I use Linux. So I would say I'm quite experienced. But yeah, as I already told you, Giuseppe, this morning, I ran into different issues with the VirtualBox, and it's always fun to debug stuff. Yeah, mostly not. But yeah. Yeah, Python and R are my main programming languages, and I would be really interested to fill the gaps that I was identifying during teaching myself all these programming languages and JS software. Because now, yeah, I guess you have much larger background, and I'm very happy to see how it goes.
Thank you, Alex. Yeah. Julia.
Yes, my name is Julia. I'm a PhD student at Stockholm University, and I'm originally from Germany. And in my PhD, I'm focusing on mapping soil properties, mainly carbon stocks in the Arctic. And I'm also mapping land cover and landforms. And I'm also using some machine learning algorithms for that. And yeah, my main programming language that I use is R. I rarely use Python, but I'm more familiar with R. And I'm also using several JS software, QJS, ArcJS, and so on. I have some experience in Linux already, but I'm using mostly simple tasks in the command line like GDAL, raster processing, and also the Saga command line tools. And from this course, I hope that I can combine and automate processes better, and also learn parallel processing, and also get more knowledge about different machine learning and deep learning tools. Yeah, that's it.
Thank you, Julia. Alejandro.
Yes, good afternoon to everyone. My name is Alejandro. I'm originally from Colombia. I have a bachelor in physics and a master in meteorology, also another master in climate science. I'm a PhD at the Department of Meteorology at Stockholm University. I'm working mostly with climate dynamics and radioactive forcings in the tropics. I mostly have used data from models, so I run models. And recently I started using data from some intercomparison projects. So for this data, I don't run the model, I just download. And also from satellites. I have experience on Linux, and I would say that the main language that I use for coding is Python, but I've done some tasks on R, also in QGIS and so on. I expect from this course to broaden my knowledge in most in technical skills, and also to deepen machine learning.
Gracias, Alejandro. Juan.
Hi, everyone. I'm the third Colombian in the group. I'm doing my postdoc at Stockholm University. I'm ecologist by training, interested in how ecosystems change, and whether we can detect abrupt transitions in ecosystems from remote sensing products. My background includes some programming in R. Sometimes I've been using also Julia and a bit less so Python, but as some of the other participants, I'm very inclined to use open source tools. I think that's all from me. What I would like to learn more of the course is more on statistics and machine learning perspectives for special problems.
Thank you, Juan. Farzad.
Hello, everyone. Can you hear me? Yeah, I'm Farzad. I'm last year a student at Bologna University in Italy, but now, like a couple of months ago, I started my master thesis here in Department of Physical Geography at the Stockholm University, and my master thesis is related to monitoring of the wetlands, and I'm using the remote sensing data, so I'm somehow struggling with a lot of raster data and image processing. So yeah, a couple of months I started to also coding in Earth Engine, which use JavaScript language. So yeah, I'm also a bit familiar with Python because I'm used the Python with scripting QGIS, PyQGIS, and I have not a lot of experience with the Linux, but I'm also used the bash scripting in Mac, so it's somehow the same as the bash profile in on Linux. So yeah, so it could be considered as a experiencing with Linux. And I'm also used the GDAL scripting for like simple like converting the GIS different GIS formats and like converting the projection of the raster files, and a little bit of R during the courses, the master, and yeah, that's it.
Thank you, Farzad. Abdel?
Yeah, hello everyone. Yeah, I'm not a PhD student, so I'm a lecturer at MISU, where Alejandro comes from. So I wanted really to learn a little bit more about machine learning for various purposes, like supervision, for example. And it is, yeah, I mean, machine learning is now something, it's like a byproduct. And so I wanted to learn a little bit more. I use Linux, but basics. So I don't really program in Linux, but I use Linux for everyday purposes. I mostly program in, I started, of course, with Fortran, and then I moved after that to S+, and then to MATLAB. I have really basic knowledge of Python. Yeah, so that's all I have. Thank you.
Thank you, Abdel. So as you can see, I heard about all of you. We have a big variety of people coming from different field and application, with also different. This is the response of the forum the questionnaire that I sent to you 2 weeks ago. As you can see, we are in a situation where there are people from in the beginning of the coding experience, but we have also advanced people. And some of you are more have more Python background, somebody more Bash, somebody R. So we will try to have a combination of all the situation, and I kind to people, say to the people, asking to the people, the beginner, let's say, to speed up during the process. So keep working hard, let's say, during the week, in order to arrive to, in this way, to the next lecture, we can go one step level more. And I also ask to the people, to the advanced people, to wait a bit, let's say, and to wait a bit for the people that are in the starting line. I will try every time to mention, to make a summary of what we are going to cover next lecture. In this way, you can figure out is something that you already know, or eventually if you can completely skip, or you can focus, or you can also listen, and meanwhile you do something else, and when something come up that you don't know, you just pay attention. This is also quite often done with the people that are already in advanced mode. We will cover, like I mentioned, we will try to cover a bit of everything. We will not cover so much R programming, because most of you already have a good background in R, and also most of the university have already programmed in R. So we will focus more in the Python and Bash and application, like geographical application like GRASS and GDAL. And R, you will see, even if you never touch it, whenever you know this Bash, Python, GRASS, GDAL of doing R will become in automatically. So it's not a big deal to start by yourself. We will focus also in GRASS, like I mentioned to you, for geographical application, mainly in hydrological modeling. This is one of my main research line that I'm doing. And of course, we will try to integrate also in the parallel processing and in the Bash environment and Python environment. We will focus on. Concerning I also tried. There were several people wrote, let's say, yes, you have a quite good understanding of mathematical statistics. So let's say, Alonso was very happy to see that you have all of you take already calculus 1 and 2, and also some good basic of statistics, so he can push forward to the machine learning fundamentals and so on, and do it also the application. And for sure, you have already GIS and remote sensing, so I will not need to explain you what is a raster. I can go directly to, okay, let's change the resolution. Let's reproject this data without explaining. So this was quite good to see that we can push forward. Then there were some free question, free task that I was asking to asking your main tools and library that you want to and see, and also the motivation why attending the course. And I tried to summarize some of them. There were some of them that were really mentioned the same way. So like I mentioned, we will tackle all these software, and in particular for the machine learning, we will have also Keras, TensorFlow, PyTorch for some application. Over here, this one will be mainly covered by Lonzu, but also from other speakers that are working in this field. We will touch also parallel processing in Bash in Python environment. Of course, we will not do it massive processing because the virtual machine is still small, but we will give you skills, we will give you example, and we will run also the example, but in a small data set, and then later on can work also in supercomputer, in supercomputer under the Bash and Python environment. We can potentially also, I will try to talk if Sweden University has a high performance computing that is available for you guys. We can try to, I can try to ask if all of you get an account, and me too. In this way, we can do maybe 1 or 2 days of high performance computing in your cluster. I have also a video lecture that is already available, so I will point to you where it is. So we will try to achieve this parallel processing. Like I mentioned to you, the machine learning, we will see the theoretical fundamentals and also application, and also in the supervised and unsupervised classification for classification, and not only for classification, but also in the regression analysis. So yes, we will working with the image processing, mainly raster environment. So we are not going to touch so much the vector environment, or just sometimes for doing some clipping or boundary, country boundary, and so on. Mainly will be raster data, because over there is where the massive data process can happen, especially for the time series application and multidimensional, the so-called data cube query language, and so on. So what is possible at acquiring with the course? Of course, say in a really broad and super efficient way. I would like to see a bit of everything. Yes, this is true. We are not going to focus in one subject specific. So we are going to try to expand our knowledge and give you different tools and skills that you can later on leverage as you want. I like this sentence, so I put over here, I'm able to run extensive spatial data stuff quickly and without pain. Okay, without pain, I don't know, because we always have pain in doing this kind of application, even after several years. But the pain will be reduced through the course, because we will teach a lot of tricks.
Can anybody still hear Giuseppe? He's off.
I've also lost audio from Giuseppe.
Yeah, same here.
Same here.
Okay.
Same.
Yeah, I just text him. I don't know what's the situation. Well, I think he just dropped. We got 17 people right now. I hope he'll come back in a minute. In the meanwhile, just fill the gap, say something about myself. Oh, forgot to turn on my camera. Yeah, I was very excited to view the class survey from everyone you provided. Basically, I look at this problem, if you think about the high level from a modeling. I don't know what you guys think about, from my perspective, modeling is pretty much about the philosophy. So there's a famous mathematician from Oxford saying there are three worlds in this whole universe. One is the physical world, which is basically we observe, we see whatever reality it is, if we believe that's reality. And it's a mathematical world where we leave all these symbols and operations that can help us to mechanically calculate, estimate, and perform a lot of mathematical operations and get outcomes. And the third one is about emotional world, which is basically what's in our brain. So the final task for every one of us from our journey, not only for the course, also for our life, is pretty much how to connect these three worlds together to form your own philosophy. So put this in perspective in the field of geomodeling. What I see geomodeling is basically how to elevate the geographical representation from the world and transfer those into the mathematical language and make a projection and the concrete, precise representation what we can see from the ground and the surrounding us, and use this one to model and help us to understand the physical world. And it's also about the emotional world. Basically, we have to connect each other because it's always the learning process. Many of you mentioned about machine learning, and in my talk, I'll talk a little bit about the machine learning and human intelligence. Yeah, I think I just filled the gap now. I think Giuseppe is coming back. Giuseppe, you're back?
Yes, I'm back.
Yeah, I just filled the gap with some entertaining topic. You can continue and carry on.
Perfect. Yes, leave me 1 second. I give you the hosting also, just in case. There was a so on Zoom. Make a co-host. Okay. It's still recording, isn't it? Yes, it's still recording. Okay. Okay, let me see if I can share it now. Okay, perfect. Yeah, thanks, Ronzo, for cover this part. Yes, so so the material be stored at the spatialecology.net, like I mentioned to you. We will sharing data set and lecture via GitHub, and we are going to have online recording like now every lecture, then will be posted directly inside to the spatial ecology spatial ecology website. I create a Slack channel that I send you an invitation where we can troubleshooting and let's say having additional support. We will try to we will give you assignment or let's say little exercise that you can keep doing during the your free time. We will not grading any courses, not for having credit, but I strongly suggest you to do it this assignment in order to push forward the next step, and especially for people in the beginning. If you want to working towards your final project, we will have a final project in the end where you're presenting your scripting procedure. It's really up to you. If you this subject is towards your PhD, much better for you, let's say, because we'll be helping you to push forward the analysis for your PhD, so you can present already some analysis that you have done for your PhD. So we will try to have these presentation of the final project in the end. Just a little bit of what is behind, let's say, this computational frameworks in Linux environment, and why we are using this. Whenever you start a project, you're starting always from raw data that can be image, can be climate, biodiversity data, economical data, landscape data, and so on. So these are really the so-called nowadays the big data. Okay, so over here you have to really working towards the command line for reducing, really filtering, harmonizing, gathering, cleaning the big data. Okay, so then whenever you do this analysis, that most of the time has to be done in coding, and for example with GDAL, with the PK tools that can manage really large image, then you can focus the second part of the analysis for the statistical physical analysis. And over here you can play R and Python play an important role, let's say. Then you have again these graphical table and summaries, and the website presentation, manuscript, your article, your thesis. So every time that you this kind of application, this kind of flow has to be repeated several times. So it's not like when you do the clicking procedure that you start from here and you go very slowly, step by step, to process, and you don't want to make mistake because you don't want to repeat the clicking. In the coding, especially my philosophy is really quick and dirty from the beginning until the end. And when you arrive to the end, then you're restarting the procedure. Okay, but it's very important to see if you can arrive to the end, and then you can redo the analysis, improving the model, making more complex, increasing the data quality, increasing the data quantity, and so on. So this really give you already a feeling if your final code is going to work or not. And also because you can encounter, let's say, statistical and mathematical limitation for your modeling, but you can also encounter during the process a computational limitation. So this will be driven your final output. So you need to have this, let's say, from back forwards several times in order to improving every time. And this is extremely important to have code that are really in a processing chain, especially when you're working in the supercomputer. You have to have 1, 2, 3, 4, 5 each single script that really process the data in an automatic calling the second one, and so on, because you want to have all this flow completely connected. And of course, if you do this analysis with the CDO and with the GDAL or raster, then you want that these GDAL, raster, GDAL, and GRASS talk with the Python and R for the statistical analysis. So all the language need to be talk each other and be able to transfer files, variables, and setting, and so on, and parameters, and so on. So this is only possible under Linux operating system that is able to let really the language to speak together. So why using I think I can go fast on this because probably already most of you can heard about this open source philosophy. You have is extremely security, is super stable, can be run under the open source software, can be run under Linux, Windows, Mac, and so on, different applications. But I have to say the truth that under Linux, the open source software, they work better. The integration between them is much better than not if you, for example, if they work in Windows. You can have 1,000 of applications. There is always the let's say the brother for the commercial software. There is also the open source brother. So just when you know one software that is commercial, just write alternative of this software for open source, and it will come up a bunch of them. You have the freedom to really configure, develop, distribute, and it's fun. Okay, it's fun to do it. You will see it's a pain in the beginning, and it's going to be painful also later on during the journey, but with the time it will be coming much faster. So you have the freedom, let's say. And why is fun? for several reasons. First of all, you have really the code, so you can really understand what is behind the process. Okay, you can able to modify the as you want the code. You can write your own algorithm, so you can combine different function. So you are not really linked to a physical button that is there that you need to click. And you can use the software without constraint. So this is also very important. If some of you will go in the direction of working with, let's say, inside to university, but also with the NGO, they don't have so much money to buy licenses. So it's very appealing for this aspect. Something that I really like it, that I use it when, let's say, the pain is quite a lot, that I don't find any other alternative, is getting help from mailing list. There are the R mailing list, the GRASS mailing list, that GDAL, that are really really on the front line of helping people and distribute their knowledge. And something very cool that you can really talk with the developers. I know the developer after several years. I know in person. I mean, in the beginning through emails, and then in some conference we met and say, you were helping me in that. Yes, I remember. And so it's very, there is a straight line to the guy or to the person that was developing the code. So this is really super appealing to understand who is behind a simple complex GRASS command or under a GDAL implementation and so on. Then it's also fun because you can really touch and modify and the job priority processing. For example, you can say, okay, let's run this job faster than the other one because I'm more interesting or because it's more longer. So give more resources, especially together with the job scheduling in the supercomputer. So these play an important roles in let the process going as you want. You can also working with RAM management. You can really understand how much RAM is using each single processor, how to coding more efficiently, and debugging, not only debugging from the syntax error, but also improving the speed of the code during to a better performance of the language, or writing in a better way the language. Really also really funny that you can work with a remote server. Quite often I just bring my mobile and my laptop, and by the data connection I log into the Yale cluster, so I can run my my scripting procedure, and I can see how it's going. So it's really in this aspect is really cool. Hardware resources storing temporal file, storing temporal file in RAM. So we will see how to be more efficient working with RAM, and when the RAM is more important, or when the RAM is filling up, what to do and how to achieving better task if our RAM is not enough. So really play between the RAM and the hard disk writing, let's say. So this will be quite cool to see and see the different application, and really getting the best of each programming language, because unfortunately there is not the language that is the best for everything. So is a bit like a foreign language. You try always to know more than 2 or 3, and then the fourth one will be almost automatically. So this is really, and something really really important is if you code properly during the way, you can enjoy during the night when the PC is working for you. So so this is really important to achieve this goal also during the PhD, because we need some free time. But in the meantime, the computer can run jobs. So if you do it properly, the computer never stop, let's say, and of course the result will become much faster. So this is a bit a flow that me and Lunzu, we used to have in our operating system, and also in our mind. Let's say we have really the Bash language as a glue language for all the different applications that we have that we use it. So we will have QGIS and GRASS and GDAL for remote sensing application, and also Orfeo toolbox. R and Python for the mathematical and statistical analysis, Oak for the text processing, PK tools, Open Forest also for the application in remote sensing and raster processing. So the Bash language for us is the glue, but it's also true that in the last years, especially people with already knowledge in R, let's say they call all the software through R, or people already in Python, and I would say even people mainly coming from Windows environment, so they don't have the Bash console. Let's say they use this approach to have Python in the center and calling all the different language. So during the course, we will see a bit. Are you seeing my screen? Yes. Can you see my screen?
I see the screen. Yeah.
Ah, okay, perfect. So I will see some message coming. I was not sure.
There's a message also. Know where the message come from.
Okay. See, so the Python can also integrate all this language together. So we will try to be more on the first approach, let's say having the Bash language a bit in the center, but feel free to change a bit all this using all this second operation and so on. Okay, perfect. So I think we will try also to have a break. Like now, we are going to go for a break, 10 minutes break. So we will come back at 15. Let's say at 15, whatever is your time over there. And the meantime, I will setting up my Zoom because now it was a bit in the browser now when I started again. And then Lunzu is going to talk a bit about his overview about the lecture that he's going to give from next time going on. Okay, see you at 15.